Yeah, welcome. The topic we will be discussing in this session is CPU scheduling. So the objective of the CPU scheduling is basically we'll be discussing concepts in this lecture series. We'll be discussing the basic concepts of CPU scheduling. Why should we go for scheduling? And then we'll be discussing scheduling criteria. That is, there are different CPU scheduling algorithms are available. So, under which circumstances, which algorithm should be used, and how to measure the performance of these algorithms? On based on what criteria the performance of these algorithms can be measured. That's what we'll be discussing under scheduling criteria. And then we'll be discussing various CPU scheduling algorithms. Right? So the objective of this particular topic is to introduce CPU scheduling. So CPU scheduling is, is the basic thing which we do in a multi-programmed operating system, in a multi-programmed environment. So we'll understand what is meant by CPU scheduling and why it should be done and how it improves the CPU utilization. That's the first objective. And second objective is to discuss the various CPU scheduling algorithms. Okay, fine, let us start. So let us understand the basic concepts like why should we go for CPU scheduling. So, so let us consider a very basic case where there is a single process, where a computer is running a single process and it is not a multi-programmed environment. It is not a multi-programmed environment. That is, the CPU once allocated with one process, it will it will complete that process. Then only it will go for another process. Okay, so such an environment is not called as a multi-programmed environment. So there is a CPU, and it takes one process or one job, then it completes this process. Only after completing this, the CPU will take the next process. Until the process one complete, until the process one has not completed, it will not go for the next job. For example, if process one is waiting for any IO operation, then CPU also will wait in that case. Okay, CPU also will wait. CPU will not do another job. Okay, so such an environment is called as an single programming environment, or which is not a multi-programmed environment. So what is the drawback of this environment? The drawback of this particular case is CPU is not being utilized effectively because the process is performing an IO operation. So at that time CPU is also waiting. So it means that you are underutilizing the CPU. So rather what can be done in the sense, if there are multiple processes, you can keep all those multiple processes queue, in a queue. And when any process is doing an IO operation, then some other process from the queue can be brought in and CPU can execute that. Okay, so by that what happens in the sense, the utilization of the CPU increases. Okay, so basically this is the core purpose of CPU scheduling, because any process if you take, it includes both CPU related tasks and also it includes IO related tasks. Okay, but when the process is performing an IO operation, then the CPU is not being used. Then during that time, some other process can be executed. So that concept is called as multi-programming. Okay. And if you take any particular task, any particular process, it is just a combination of CPU burst and IO burst. What is the CPU burst? CPU burst means it is performing the process is performing some task which needs computation. Okay, CPU burst means, it means during that time the process is performing some task which needs computation. So it is CPU burst means it is computation intensive tasks. CPU burst means it is during that time it is performing a some computational operation where the involvement of CPU is required. Okay, and IO burst means during that time the process is performing some IO operation, or it is waiting for some IO device, or it is performing some IO operation. So that is called as IO burst. So any process if you take, it is a combination of CPU burst and IO burst. Okay, so you can see this diagram. This is a process. So so you can see there is a combination of CPU burst and IO burst. Initially, it is performing some CPU burst. Then there is an IO burst. So it means during this time, this process is waiting for the IO to complete. So it is in the wait state. It is in the wait state during this time. So what can be done in a multi-programmed environment? During this time, the CPU can be allocated for some other process. So if this is process P1, then during this time, maybe another process P2 can execute, right? And once this IO completed, again CPU can be given back to P1, so that now it has some CPU burst. Again it has IO, again it has to wait. So again so I'll call it as, whenever there is IO there is a wait. So again during the while it is waiting, the CPU can be given to process 2 or any other process. Okay, so so this is called as effective utilization of CPU. So this can be achieved by uh, uh, CPU scheduling. Okay, so with CPU scheduling, the CPU can be utilized to the maximum extent possible, so that the core resource or the main resource of the computer is getting utilized in a proper way. So this is the basic reason why we go for CPU scheduling. Okay, so then so there is a, so the researchers over a period of time, they have they have studied normally how a process behaves. Of course, a different process behaves in a different way. Uh, but the researchers and engineers and scientists, they have studied typically how a process behaves by studying process of different length. Okay. So finally, what they concluded in the sense, so there will be if you take a if you take any typical process, it will have it will have more number of CPU burst with short duration. It will have more number of CPU burst with short duration. What is CPU burst? CPU burst means during that time it is performing some computation task. Okay, CPU burst means what? During that time it is performing some computational task. So the researchers, what they identified in the sense, by going through or by studying the behavior of many processes, they understand that typically how the process behaves in the sense, it it uh, it it produces more number of smaller IO CPU burst. It produces more number of smaller CPU burst. Okay, so small CPU burst in the sense, it is, as we have already discussed, it is the compute. So it is a computational intensive work. Okay, so there will be more number of small CPU burst of small duration. Okay, there will be more number of CPU burst of small duration. There will be more number of CPU burst of small duration or shorter duration. That is, the time interval uh, uh, will be very less. Okay, so you can see this diagram. So this graph, you can see this peak point. This peak point, it is somewhere between 150 158. So frequency means how much time such a request comes. So that is what the x-axis says. And if you say y-axis, it is the burst duration. So basically it is CPU burst. Okay, it is not IO burst, it is CPU burst. So what is the burst duration, CPU burst duration? So if you see this particular peak point, its duration is what? Its duration is somewhere here, which is probably 4. Okay, 4 or 5 maybe. Okay, so it is a CPU burst for 4 milliseconds. This is in terms of milliseconds. So CPU burst for 4 milliseconds. It has occurred for how many times? It has occurred for 158 times. So that is what this study says. So typically if you take a process, it will have more number of CPU burst of shorter duration. It will have more CPU burst of shorter duration, and it will have less number of CPU burst of longer duration. So you can see there is very less number of CPU burst of during this duration, from 8 milliseconds to 40 milliseconds. So if you take 8 milliseconds to 40 milliseconds, the CPU burst is very less. The number of CPU burst is hardly hardly one. Okay, this point is hardly one. So hardly there is mm, one CPU burst, which is for 8 mil, which is for 8 milliseconds or 16 milliseconds or 24 or 32 or 40 milliseconds. Okay, but if you take this particular thing, you can see there are more number of uh, short CPU burst. Okay, are you getting? So that is what this particular graph says. Okay, so 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 generally what we can say in this sense, uh, normally IO bound processes. So previously we have discussed what is an CPU bound process and what is an IO bound process. A CPU bound process is one which performs most of the time it performs computational task, whereas an IO bound process is the one uh, which performs most of the time IO related operation. Okay, so in a CPU or in an IO bound process, if you take a typical IO bound process, in a typical IO bound process, there will be more number of shorter CPU burst. Okay, in a typical IO bound process, there will be more number of shorter CPU burst. Okay, and in a typical IO bound process, in a typical IO bound process, there will be more number of shorter uh, CPU burst. Okay, and in a CPU bound process, a CPU bound process in the sense which utilizes CPU most of the time. In a CPU bound process, there may be in a CPU bound process there may be few CPU burst of longer duration. Okay, in a CPU bound process, there may be few CPU burst of longer duration. Okay, I think the point is clear. In an IO bound process, there will be more number of CPU burst of shorter duration. Whereas in a CPU bound process, there may be few few CPU burst of longer duration. So so this is just an understanding of normally how a process behaves. So what we can see in the sense, in a typical process uh, there will be more number of CPU burst of shorter duration. Okay, and there will be very less number of CPU burst of longer duration. That's what the graph says. Okay,